On the left-hand side are the policy tools. Through these, the user can implement changes. These changes will be visible on the globe on the right-hand side. In this world, countries as we know them do not exist, but they are represented by 320 triangles. Now let's start playing and have a look at one of the policy tools, the diet planner. By opening the diet planner, we can see 3 preset diets which have been already prepared for you. On the globe, you can see how these diets are distributed. Let's take as an example the Japanese diet. When clicking on it, we are able to visualize how much of the 8 food categories is consumed in this diet. Here, the player can use the sliders to implement diet changes or even create a whole new diet. Now, let's take a look at another policy tool, the Land Use Survey. Here we are able to see the 5 primary types of land use across the globe: urban, green, water, agricultural, abiotic. We can represent different data by activating the visibility layers at the bottom right of the screen. For example, when clicking on production, we can see the amount of agricultural land as an extrusion. Same goes when activating the layer population. Now let's travel in time. When going for the next 10-year turn, the hunger scoring system is shown in red. During the turn, we can see the years passing by and we are able to evaluate whether hunger is increasing or decreasing. These fluctuations are created by the yearly difference in harvest. As we saw, the hunger levels are high. Let's try solving this issue with another policy tool, the Trade Creator. First, let's activate the spatial balance layer. This tells us whether a triangle has an overproduction of food, shown in green, or a shortage, shown in red. We can try now to find our solution by activating the neighborhood trade. This tool allows a triangle to trade with its direct neighbors. Let's check the results in the next turn. The change has worked. Hunger has now drastically decreased, but it has not disappeared yet. Let's investigate why. We have activated again the spatial balance layer and selected the most problematic triangle. We can see that there is an overpopulation of 202 billion people. 17% of agricultural land is not enough to cater for them. We need to look for a different solution. Let's go back to the diet planner and try changing the diet. Before applying changes to the diet, we activate the demand visibility layer to visualize the changes. First, we increase the vegetarian diet, and then we decrease the amount of meat. Let's run through another turn. Now we see that conflicts, shown in black, are rising because the hunger problem was not resolved quickly enough. As a consequence, green will decrease and trade and production will be less effective. While playing, we need to keep in mind that the type of diet that we choose or create will have an impact on the amount of carbon emissions and therefore will determine the speed of climate change. Through the climate monitor, we can keep track of this during the simulation. In this case, we can see that the carbon emissions produced by food production are too high. How can we solve it? A new challenge is in front of us, and the fun can continue.